Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 1 of weekly contest 464 GCD of odd and even sums. So you are given an integer n. Your task is to compute the GCD, greatest common divisor of two values. Sum odd, the sum of first n odd numbers, and sum even is nothing but the sum of the first n even numbers. We have to return the GCD of sum odd and sum even. So very easy problem. So n is equal to 4. That simply means I need 4 odd numbers. First 4 odd numbers and first 4 even numbers. Right? First 4 odd plus first 4 even. So total 8. Right? So here first 4 odd numbers are 1, 3, 5 and 7. And what is the sum of them? 16. Sum of first 4 even numbers is nothing but 2 plus 4 plus 6 plus 8 is 20. Now we have to calculate the GCD, greatest common divisor of sum odd and sum even, right? So our output is 4. How we calculate the GCD of two numbers? So 16, right? So here if I solve this 16, 2, 8 here, right? 2, 8 is 16, 2, 4 is 8, right? And here 2, 2 is 4, right? And here 2 1 ja 2, right? This is for 16. Now same way if I write it for 20, so 20 is nothing but 2 10 20, right? And here 2 5 ja 10, and here 5 into 1 is 5. Okay, so now here 16 I can write it like this: 2 into 2 into 2 into 2 into 1, right? This is nothing but 16. And 20 I can write it like this: 2 into 2 into 5 into 1, right? So now the greatest common divisor, right, GCD, is nothing but here if you see this is 1 only, right? So this is nothing but 2 into 2 4 here, and here also 2 into 2 4. So this is the common divisor, right? 4. So here also we are getting 4, right? 4 into 2 into 2, and here also 4 into 5, right? So 4 is the common. So this is nothing but the greatest common divisor, right? And here for this example n is equal to 5, so we are getting sum of odd is equal to 25 and sum of even is equal to 30. So GCD of 25 and 30 is 5. 5 is the greatest common divisor, right? Okay, and these are the constant size. N is from 1 to 1000. So now how we are going to solve this GCD, right? How we are going to solve this method GCD? We are going to solve it using Euclidean algorithm, right? So what does Euclidean algorithm says? So it says, let's take this example, same example, right? So here we have 16 and we have 20, right? So let's say this is a value and this is b value. So Euclidean algorithm says that if my b becomes equal to 0, okay, if my b value becomes equal to 0, then in that case simply return a. Okay, in that case we have to return a. Until then what you need to do, this is your GCD, right? Until then you have to just call this again and again, GCD, and this time here in position of a I am going to pass b value, right? So whatever the b value that I have, this is what I'm going to pass, and here I'm just going to write a modulus with b, right? Until then I have to do this. Okay, so initially I have GCD like this, a and b, right? 1620. So if my b is equal to 0, then simply return a from it. Until then you have to return what? GCD of b. Here in this side you are passing b value, and here you have to write a modulus b. So let's prove this. Okay, so here first a 16 and b 20. My b is still not equal to 0, right? So now I'm going to reach to this position. So now I'm going to call this GCD. Now here b I am passing it as 20, and here a modulus with b. So a modulus with b, what is the value of a modulus with b? So a, and here modulus with b. So here what I'm going to get, b 20 into 0 is 0 only, so here I'm going to get 16 only remainder, right? So I'm going to write 16 here. So this is first step. Now this is my b and this is my a. Again my b is not equal to 0, so again I'm going to call this. So now my GCD is going to become 16 here, and here A modulus with B. A modulus with B means A modulus with B like this. So 16, 1, 16. So here what I'm going to get 4 as the remainder. So here I'm passing 4. Now here this is my A and this is my B. My B is still not equal to 0. So again I'm going to call this same thing GCD. Now here I'm passing B first 4, and then here 16 modulus with 4. 16 modulus with 4. 4, 4, 16. Right, 4, 4, 16. So here I'm going to get 0 now. Okay, so now here if you see, this is my A and this is my B. My B becomes 0, so I have to return A. A is nothing but 4. So this is how equilibrium algorithm works. Okay, so now let's see the code. So first, this is our main method, right? So odd sum is 0, sum of all numbers. Even sum is 0, sum of even numbers. Then we have to iterate from 1 to 2n, right, and calculate sums, right? So even sum and odd sum we are going to calculate, and here I'm just going to call this method GCD of both sums, GCD odd sum and even sum. Okay, so this is the new thing, right? So helper function to compute GCD using equilibrium algorithm. So here int a and b we are passing. If b is equal to 0, then return a, otherwise we have to return GCD. Here we have to write b, and here we have to write a modulus with b. Okay, so this is what we are doing here, right? A modulus with b. So I hope that you guys are able to understand today's problem, question number 1 of weekly contest. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.